Hi guys, great to have you on board. And in this video, as I promised, I'm gonna solve this problem which is related to interfacing with microprocessor based system. So let me quickly read this question. AD converter requires signal to start the conversion and indicates the completion of operation with the end of conversion signal. 8255A PPI is interfaced with 8085 microprocessor at 80H. Microprocessor reads 8 bits output data of ADC at port A and displays the same data to 8 LEDs connected at port B of 8255A. State any assumption made. Identify the address captured by the card. Determine the necessary control word. Draw the schematic interfacing circuit and write a program to perform the operation. So now I'm gonna explain the question a little bit, but before we begin, I would like to tell you, if you haven't subscribed the channel, please consider subscribing it, because on this channel I'm constantly posting videos related to programming, technology and education, engineering in general. So this video might help you in future, so consider subscribing it. Alright, now let's get back to the question. The first statement is AD converter requires signal to start the conversion and indicates the completion of operation with end of conversion signal. Now 8255A PPI only accepts digital input, so the input given to the PPI may not be digital every time. Therefore ADC converts all of the analog input into digital input for PPI, and for that 8255A PPI sends SOC signal, start of converter signal, to ADC to start converting the inputs, and then when ADC is done, it sends back the EOC signal, end of conversion signal, to indicate that it is done. And the next statement is 8255 PPI is interfaced with 8085 microprocessor at 80H. So if there is a statement like this, interface with 8085 microprocessor at some address, then it's basically telling you that it's the port address and it's the address of port A actually. So this is what it says. And then microprocessor reads 8-bit output data of ADC at port A and display the same data to 8 LEDs connected at port B of 8255A. So this statement is pretty self-explanatory, and it's basically saying is that we are accepting input at port A and displaying that input at port B. Now the questions are identify the address captured by the card. So this question is basically asking you to write down the address of each port, that is port A, port B and port C, and the control register. And as I said, 80H is the address of port A, and the address of port B will be the address of port A plus 1. And similarly, port C will be port B plus 1, and the control register will be port C plus 1. So let me quickly write down those port addresses. So port address, you can say, and then port A will be 80H, which is already given, so you can say given, and then port B will be 80H plus 1, that is 81H, and then port C will be 81H plus 1, that is 82H, and then control register, that is 82H plus 1. So these are the port addresses. Now we are done with the first question. Alright, the next question is determine the necessary control word, and control word is the word when being output from control register defines the function of each port, and it has got 8 bits as you can see here. And now I'm gonna explain what each of these bits is. So D7, it will be 1 if PPI operates in input output mode, and it will be 0 if PPI operates in PSR mode. So let me write it down here. Input output mode equals to 1, and then PSR mode will be 0, and then these all bits are These all bits are grouped as group A, and these all bits are grouped as group B. And D6 D5, this will be 0 0 if port A operates in mode 0. So mode 0 equals to 0 0, and this will be 0 1 if port A operates in mode 1, and this will be 1 don't care if port A operates in mode 2. And there are only 3 modes, 0 1 and 2. And then we have D4, and this will be 1 if port A operates if port A is input, and this will be 0 if port A is output. And then D3, this will be 1 if port C upper is input. So and this will be 0 if port C upper is output. And by port C upper I mean PC4 to PC7. And then we have D2, so it will be 0 if port B operates in mode 0, and it will be 1 if port B operates in mode 1. And then we have D1, this will be 1 if port B is input, and this will be 0 if port B is output. And then we have D0, and this will be 1 if port C lower is input, and this will be 0 if port C lower is output. Okay, and yeah, it looks pretty messed up, but I think you have got the idea. Alright, now we know about control word, but before we write control word for this problem, we need to draw a schematic diagram, and which is also our next question. So let's do that. I'm quickly gonna draw this schematic diagram because I have already explained the schematic diagram of 8255 PPI in the intro part. So if you haven't watched it, please go ahead and watch that. So the schematic diagram of 8255 PPI looks like this. Will be reference, this will be ground, and these are the common active low signals. So read, write, and then A0, A1, and then reset. And then we have chip select. So and then since the address of port A is 8-bit, this will be IO mapped, so this will be A22 and A22 A7. And then we have data coming from microprocessor, so D0 to D7. And then on the right hand side we have the port A and port B and port C, and we already know that we are accepting inputs at port A, so port A will be input, and the inputs are given through ADC. So let's draw that to ADC. Okay, now here this will be PA7, this will be PA0, and since we are using ADC, you need to give SOC and EOC signal. So SOC and then EOC. Okay, and SOC is given by PPI to ADC. So let's draw like this, and also SOC is generally assigned with PC naught, and EOC is given by ADC to PPI. So PC7 and EOC is generally assigned with PC7, and then we are displaying those inputs at port B, so through LEDs. So let's do that. And then PB7, and then PB naught. Okay, so this is the schematic diagram of 8255A PPI, and in the book you will find so many other signals associated with ADC, but you can skip all those signals because you don't know the all these signals of all the devices like printer, keyboard, all these input output devices. So you can skip those signals. You can just write all the needed signals like PA7 and P0. Alright, now let's quickly write the control word. So D7, D6, D5, D4, D3, D2, D1 and D0. So since this is input output mode, this will be 1, and if we are using SOC and EOC signals, the mode of port A and port B will be mode 0. So we write 0 0 and over here 0. Okay, now port A is input, so we'll write 1, and then port C upper PC7 is also input, so we'll write 1, and then we are left with D1 and D0. So D1 will be let's see, D1 is port B, and port B is output, so we'll write 0 here, and then D0 is port C lower, PC0 is output, so we'll write 0 here. So this will be 9 and then 8, 98H. So this is the answer of this question. Determine the necessary control word. So this will be the control word for this question, and draw the schematic interfacing circuit. This is this diagram. So we have successfully answered these 3 questions. Now we are left with only 1 question, and so let's do that. Now while writing program, you can follow this guidelines in almost any problem. Output the control word from control register, set the SOC signal, check for EOC signal, accept the input from input port, process the inputs if required, output the inputs, and stop the program. And you may not need to follow these 2 guidelines sometimes, because sometimes will be required for enabling interrupt, and we'll see about that in next videos probably, so don't worry about that. Alright, let's get back to the writing program. So the first is set the SOC signal. So output the control word from control register. Okay, so for that we need to load the accumulator with control word, that is MPIA 98H. As you can see that 98H is the control word. Okay, so and then out 83H is the address of control register, as you can see here. So this is basically outputting the control word from control register. Okay, and then we need to set the SOC signal. So for that we need to load accumulator with control word for setting the SOC signal. Now since SOC signal is associated with assigned PC naught, so we will be setting PC naught, and for setting the PC naught the control word is let me quickly write that. Okay, now when setting any of the bits of port C, that will be BSR mode, so we write 0 here, and in setting or resetting the bits of port C, these 3 bits will be don't care. And here if you are setting PC naught, then we write 0 0 0, and if you are setting PC1, then this will be 0 0 1, and if you are setting PC2, then this will be 0 1 0. So now I guess you have an idea what to write in these 3 fields. And if you are setting, then we write 1, otherwise 0. If we are resetting, then we write 0 here. So this is the control word for setting PC naught. So that will be, if we consider don't care as 0, then this will be 0 1h. So MVIA 0 1h, and then we need to output it from control register, so out 83h. Now we need to check for EOC signal, which is issued by ADC when it has completed converting all of the analog inputs to digital inputs. And since EOC signal is assigned PC7, as you can see here that EOC is assigned PC7, so we need to read input from port C first. So IN 82H, and 82H is the address of port C, as you can see here, and then RLC for checking PC7, and then jump on 0 to loop. So if PC7 is 0, then we will jump to here, otherwise we will continue. So if PC7 is 0, that means ADC has not issued EOC signal yet, and it is still converting all of the analog inputs. But when it is not 0, when PC7 is not 0, that means that ADC has completed and has issued the EOC signal, and in that case we need to read input from input ports, which is port A in this problem. So then IN 80H is the address of port A, and then out 81H, because we need to output the inputs from port B. So port B has address 81H, therefore out 81H, and then HLT, which is the stop the program as stated in guidelines. Okay, so this is the program, and we are done with all of the questions asked in this problem.